I'm going to be talking today about SWMS. So it stands for Core Water Management System. And this is a presentation that Chan Modini, he's the chief of the Water Management Systems Division at HEC, gives. And I just added a couple little items that are specific to Sacramento District, and we will go from there. So the objective is we're going to talk about the Corps' water management mission and introduce SWMS. So we're looking at water management at the Corps, SWMS, the National Implementation Program, the SWMS resources, and the conclusion today. So the water management mission is to collect, process, store, analyze, and disseminate water resources data, to monitor systems conditions within our systems, and to make daily operation decisions at over 600 USACE reservoirs for flood risk, navigation, hydropower, water supply, and environment. And it doesn't include the numbers of our Section 7 projects we also have. So we make flood control release decisions for other state and federal reservoirs within our system. That's referencing Section 7 projects, which are called Section 7 projects because of the Section 7 of the Flood Control Act of 1944. Basically, when we say Section 7, we mean that someone else owns and operates it, not the Corps, but the Corps has a flood control mission at that project. New Reservoir and Oroville are Section 7 projects. So, and we also support other Corps missions with preparedness for emergencies and disasters, planning for future things, as well as environmental analysis, and then dam safety and levee safety. So the importance of the water management mission, it's a critical element within the Corps. I mean, and I may be biased, but because I am a water manager, but I think it's one of the most important things that we do at the Corps. I mean, and it's important because we're increasing public safety, we're benefiting the economy, and increasing public quality of life, and protecting and storing the environment. So with the Corps' water management strategy and policy, here I have listed some of the Corps' policy on water management down at the bottom, with the ERs, which stands for engineering regulations, and EMs, which is engineering manuals. And so these items really tell us, like, how do we do the analysis? You know, what goes into a water control manual itself? And all of these are available online for public. They're all PDFs. A couple of them have been updated recently. And, you know, it also details some legislation here, as well as our Civil Works initiative. But really, like, when we're doing the water control manual updates, we're looking at these ER and EMs about water control manual analysis, water control manual preparation, and that helps us get the job done. So we use SWMS to get that done. And it's an automated system, and it collects, processes, and stores real-time data, as well as provides a suite of models where we can run in real-time forecast simulations, as well as achieve a wide range of reservoir authorized purposes. So it's not just for flood control. In the West, the Corps only has authority in the flood control space, but in the East, for Corps projects, the Corps also has the authority to make the release decisions in the conservation space. So this is a tool that can be used both for flood control and for non-flood control projects. And it's really designed to meet the USACE initiatives, the water management mission, and other legislative requirements. So here's kind of a picture showing how it's done. And my visual self loves this because it's a visual. So we're going to start over here. We have observed data. It's going to go up into the satellite and the GO system, and then come down to the satellite, go into the SWMS database. It's also combined with the meteorological data into that SWMS database. And then we go into the model framework itself, which we'll talk about the CAVI here in a second, and what that stands for and what that means. Decisions are made, phone calls are made, release decisions are implemented. So that's how the Corps water management system works. So here, most of y'all are familiar with the fact that these are our modeling tools, but it really is our core of how we store and analyze our data. So, if you're familiar with how the water management section is set up within Sacramento District, we have two sides of the house. We have a reservoir operator side of the house, which I'm the team lead for, and then we have a data side of the house. So the data side of the house also uses SWMS, for their data management. So they collect it, decode it, transform it, validate it, QC it, make corrections, etc. And here's just another smaller example of how that gets acquired, excuse me. So this is a screenshot of showing like, here are all the USGS gauges. You know, to do water management, we need gauge data. You know, that's a big part of it. And so this is just showing like it's compatible with using the USGS gauges. But then in Sacramento District, we also own and operate over 100 gauges within California. So it's like where other districts within the Corps also have their own gauges and that they operate and maintain, but we have probably the largest portfolio of the districts that do that. And, you know, with the observed and forecasted meteorological data, we get data from the National Weather Service, the RFCs that provide QPFs, the qualitative precipitation, as well as their estimates and river stage and flow forecasts. So that gets implemented into the models as well. So now we're going to talk about each of the sections of SWMS and how it's broken down. And these screenshots aren't the best, but if you would like a better screenshot of them, let me know. I took this from a PDF presentation and kind of made it my own. So the first place you go is called the CAVI. So it stands for Control and Visualization Interface. And as you can see, you might not be able to, but I'm going to tell you about it. There's an acquisitions tab. So that's really about data acquisition. There's a visualization tab. So that'll help you visualize like where are you missing data. There's a modeling component here. That's where you're running all the models. And then there's just setup. This is the other tab. And, you know, the cool thing about the CAVI is like, you know, we'll talk about the individual pieces and models that go into the SWMS suite of models here in a second. But the cool thing about the CAVI is like, you can like open, you know, different aspects of it. You can open HMS from there here. You can open ResSim, you can open RAS, etc. So if you're familiar with the icons that each of those models represents, you'll see them up here at the top. So you can just click on these individual buttons and that'll take you directly to the ResSim model and you can tweak and go from there. So the CAVI is for both data acquisition and it's also to help set up, you know, your modeling tools. So here's just a brief, you know, outline of like how the suite of models works. And the cool thing about these suite of models is you don't necessarily have to use every single part of them every single time. So, you know, if you know that you're specifically going to use the ResSim model to do reservoir operations and you're going to use the RFC forecasts, like you only need to look at a piece of the puzzle. You don't have to run the entire suite. So it's very modular. You can kind of make it your own, but there is the entire suite, which we'll get into what each one of those are. But you have a meteorological component, a hydrology component, a reservoir operations component, a hydraulics component, and a consequences component. So we'll start off with the HEC-HMS, which is the hydrologic model. So it computes runoff and controlled flows given the input data, predicts inflows into reservoirs and local flows downstream of reservoirs. And it can also produce model output that's used as input for the reservoir model. Now, the great thing here too, it is very compatible with using the RFC flows because you can kind of have a hybrid, you know, model as well, where you're like, we'll run HMS for the parts we need to, but then we'll also use the RFC flows where appropriate. You can also separate it and not use HMS like I talked about before, and just use the RFC flows and go directly into the reservoir model. So the reservoir model is HEC-RES-SIM. So it gives you stream flows and water control rules to simulate reservoir operations. You can create different zones. You'll see here in this screenshot, like here's your pertinent data, your top of dam, here's your ESRD, your max release, your min release, your emergency. You have different zones within the reservoir itself that has different rules. And like, depending on the order that they're in, it creates a hierarchy. And with this, you can also overwrite operations because this model is very much like, I want to get close to the guide curve as possible. So you run the model and you're like, well, that might not actually be what we should do because we're not going to go, you know, right to our max outflow with the first day of the event, depending on the situation. So you can't override operations plans given the current conditions. And it also creates output to be used for the hydraulics model and the consequences model, which we'll look at next. So the river hydraulics models, HEC-RAS. So you're given flow hydrographs to compute water surface profiles, the downstream of the projects. And then you're predicting water surface elevations and inundation areas for the events. And the key here with this is like you're producing flood inundation maps. So this is a very key component of why SWMS exists. Probably the reason SWMS exists is because the goal is to be able to produce inundation maps during an event. So we know like where potentially flooding might happen. And then model output from the RAS model can be used for the consequences model. So the consequences model is HEC-FIA, which stands for Flood Impact Assessment, and it'll identify consequences from your flood event. And given the river stages and the data that you have, including the structural data, it computes the project benefits as well as provides an estimate on life loss as well as structural loss. And you can also use it to compute what we call flood damages prevented. That's something that we have to compute every single year to see like what would the consequences be if the dam wasn't there. So that's flood damages prevented. I can go into that more later offline because that's not the goal of today. So essentially putting it all together, the SWMS model is a real-time hydrometeorological data. It provides that. It can use weather forecasts. You can use various forecast alternatives or scenarios based on your calibrated data or real-time conditions. And you can forecast alternatives for a variety of scenarios that are simulated and evaluated in the decision-making process. So, and this is just some brief SWMS National Implementation Plan. It's a joint effort between our mapping, I always forget what MMC stands for, but it's, which is not good. I should remember what that stands for. But with the MMC and HEC, those are core organizations. And we're developing SWMS models for the entire portfolio within the core. So let me show you the next map is like a map showing like what the implementation plan. Here are the 7 like areas within the continental US of where each of the SWMS models are being implemented, where you don't see watersheds, like you'll see stuff in Utah or Nevada right here. That's where flood control projects are not located. And so it's a 10-year program. We've been working on it. And as of January 2020, 142 watersheds have been successfully implemented. So here's the latest map with that. It kind of breaks it down on status of where everything is located. So like the brown is the projects have not even been started. And then the orange is where the SWMS models have been started, but they're in progress. So if you've seen a map for Sacramento District, we cover 8 states. And so this is basically the boundary of Sacramento District. So our Utah and Colorado projects are currently being worked on at the moment, so they're orange. Yellow is district implementation in progress. So once the models get created, because they get created by, it could be a number of people. You could have people in Georgia, Minnesota, and Sacramento working on the creation of your SWMS model. But once it gets created, the district needs to take it over and make it its own and use it how it sees fit. So that's the current stage we're in with the watersheds in California. And then the blue is they're running models in real time. You see a lot of that in the Midwest and the East Coast. And then the green means fully implemented. So in core speak, that is, you are able to create a map, an inundation map. You're running them in real time and you have a backup database. So essentially, I'm not going to go through all the details on this, but SWMS can be used for other things such as dam safety, levee safety planning, consequence assessment, like we talked about. So it's a big tool that can do a lot of things. And here's just some resources. You can go to the HEC webpage for resources. One thing of note, the public version of SWMS is called HEC-RAS, which stands for real-time simulation. The difference between SWMS and the public version is SWMS uses our Oracle database, which ties directly into our database, and the SWMS, the HEC-RTS does not have that Oracle database component. So this is a public web page that you can look at to look at the, courses that are offered, the user manuals, etc. on that web page. Then there are a couple of internal web pages that we can go to for help. We have Discourse. We've also started using Teams a lot for our SWMS model help and implementation. Then we have a SharePoint site as well. But in conclusion, basically, like the goal is to use SWMS for data management, for having a solid model for the entire core to use for water management. And ultimately the goal, I said the goal was to create, flood inundation maps during an event, but it's also like if Minnesota needs help because they're actually having a flooding event at the moment, we from California can go out there and help, and we know how to use SWMS. So it's not, you're still going to have your startup, getting familiar with the projects if you're helping in a different environment that you're not used to, but you know how to use the tool. So that is another reason why the core is gearing towards using SWMS. And there's lots of trainings about there. There's a full range of modeling software, etc. And that's all I have. So thank you.